morning class. Our topic today is based on the atomic structure and interatomic bonding. As you can see, there's our group members, and I will be starting off with our introduction, the types of interatomic bonding, explain materials properties, and example difference between graphite and diamond. Objectives: discuss atomic structure and bonding to understand material properties. Atomic models: Bohr model, electrons orbit the nucleus in discrete energy level. Wave mechanical model, electron exist in probability clouds, orbits around the nucleus. Difference between Bohr model and wave mechanical: Bohr model is more simplistic, whereas wave mechanical is more accurate. As you can see, there's our graph showing wave mechanical and Bohr model. Thank you. I will be discussing question number 2 also. Quantum mechanics governs energy level by stating that one quantum system can only exist at specific discrete energy level. Electrons exist in quantized energy state. Energy transition involves absorption and emission of spectrum. Emission of spectrum still shows the wavelength of light emitted by the existing atom appearing as bright lines. The process of emission spectrum: when an electron in an atom moves from a high energy level to a low energy level, it releases energy in the form of light. Absorption spectrum shows the wavelength of light absorbed by atom appearing as dark lines. The process of absorption: when light passes through a substance, some wavelength of light are absorbed by the atom, causing the electron to jump to a high energy level. Thank you. I now give this time to my next member.
Good morning, sir. Today I will be explaining energy versus interatomic separation. Okay, so these are the two graphs that we'll be discussing on. I'm sorry that it's upside down, but I hope you understand. But in this, if you see in this graph, it is a repulsive force in the top region, and in this graph you can see there's an attraction force. So I'm gonna tell you why the repulsive and attraction here, and I'll explain how it all goes. Okay, so as if in this line here, this is where when the atom travels. So this is the distance. So atomic separation is also the distance of the two atoms when it travels close to each other. So when atom starts to get close to each other, it creates an attraction force. It creates an attraction force. So as you can see, the line goes down. So when the atoms go into the lower region, over here in this graph here, we'll be mostly using the protons, and in this graph we'll be mostly using the electrons. Okay, so in this graph, so when the atoms come into the lower region, when the system is negative, see the negative side. So when the system is negative here in the lower region, it will attract the positive parts of the atoms. So the positive part of the atom is the protons. So the protons will, since the system is in negative, so it will attract with the protons. That's given a attraction force. So in this region, this is where the atoms attract. Okay, but if the atoms continue to travel up, what happens? Energy increases. So when energy increases, the system becomes positive. Okay, so when it reaches this state, when it reaches into this positive state, what happens when the protons try to attract, it can't, because the system is positive. So positive and positive cannot attract, so thus it creates a repulsion force. That's why a repulsion force is on the top. And for this one, we'll be dealing with the electrons. So again, as the atoms travel across, what happens? As they get close to each other, they create an attraction force. So, and if it were to go up the graph to the positive, so here, since I said over here we'll be talking about the electrons, so the electrons are negative. So when it goes up into the top region, what happens? Since the system is positive, it will attract, because positive and negative will attract. That's why there's an attraction force. So if it goes up, see this dotted line, if it goes down, there'll be attraction force. But if the electrons or the atoms continue to travel and go down the graph, what happens? So when you go into the lower region, system becomes negative. So the electrons try to attract when the system is negative, it cannot. So thus when negative and negative try to attract, they cannot, so a repulsive force. That's why in this region there is a repulsive force. And also on graphs it's labeled RO here and EO. Okay, RO is equilibrium separation. This is when atoms are its most stable, most stablest, and EO is the energy, is also called bond energy. Okay, so EO is the amount of energy required for it to break. That's why from this region, if you see over here, this is where it attracts. So this is the amount of energy from here to right up to here. That's why from here up there's a repulsive force. So it's the amount of, this is the only amount of energy you need to separate. Thank you.
I'll be also discussing part 4, which is bond types. First is ionic bond, which are formed by metal transferring electrons to a non-metal. It has a strong electrostatic force of attraction. Next we have covalent bond between two non-metals. It is sharing of electrons. Then metallic bond between two metals. Metallic bonds has strong and sea of electrons, which enables them to conduct electricity when weak van der Waals forces of attraction. So weak that it cannot conduct electricity. Weak attachments, it has a low melting and boiling point. And lastly, hydrogen bond. Hydrogen bond is a special type of dipole to dipole attraction between molecules, not a covalent bond to a hydrogen atom. To conclude, atomic structure determines bond type. Bond types influence material properties. Example, hardness and conductivity. We have learned 5 types of bonding: ionic bonding, covalent bonding, hydrogen bonding, metallic bonding, and weak van der Waals. And it also helps us to understand which material to select in engineering application. Thank you.